Hello, my name is Val. Today is the next day in my marathon where I solve leetcode problems in PHP, make videos while doing so, and you can watch these videos now or later. Today is the 11th day. We have 11th of November, and we have another medium problem. The problem is called prime subtraction operation, and this problem is no longer about bitwise operations. It is actually about arrays. So we are given a zero-indexed integer array nums, and we can perform the following operation on some of the elements of this array. Now we can subtract a prime that is less than the element of the array from that element. And the question is whether we can convert this array into strictly increasing array by applying an arbitrary number of the operations that we can apply. So if we try to formulate it another way, can we convert an array into strictly increasing array by subtracting primes from some of its elements? Maybe we will subtract from all of them. Maybe we won't subtract from any of them. So for example, here we already have an increasing array. So we don't have to subtract anything here, but actually we can. If we subtract 5 from all of them, or actually it can be 2, let's subtract 2. So 6 minus 2 is 4, 8 minus 2 is 6, 11 minus 2 is 9, 12 minus 2 is 10. So we still get increasing array. So, okay, how would we solve it? I would suggest that we try to implement a greedy algorithm here. So basically, we will try to make every element of the array as little as possible by subtracting as big prime number from it as we can. I'm not sure that it's going to work because this is one of the features of the greedy algorithm. Sometimes they don't work because they give the wrong answers in some edge cases. I cannot see why we will have such edge cases here, but maybe I'm missing something. And also sometimes they don't work because they took too long time to finish. So in order to do to implement this greedy algorithm here, I would need to know which numbers are primes. For that, I would simply bring in the primes like that. These are all the primes less than 1,000. The 1,000 limit is coming from here. If you want to generate those numbers programmatically, you're welcome to do so. There are plenty of mathematical algorithms that you can implement yourself to generate that array. And also, since I stated my goal as trying to subtract the maximum possible number from any element of the array while keeping this array increasing, I would need to be able to, if the number that I have, like for example here, right, I have 6. Okay, bad example. Here I have 5, right? From 5, I would try to subtract 4 because 4 is going to be the next, the biggest. I need to have at least 1 as a element value, right? So 4 is not prime number. I'll have to find the number that is strictly less than that number 4. So this array maybe is not going to be a very good choice because we will have to do a lot of array search operations, and instead I will create an array that is derivative of this, like this. So what I'm going to do here is create an array where we have primes as keys and true as values. So basically, yeah, if we have the key, this key in array, it means that it's a prime number. If we don't, the number is not prime. Array combine is a function that takes 2 arguments to arrays. First is the array of keys, and second is array of values. Now we are going to iterate through the whole array of numbers that we were given. And for each number, we need to know the value of the previous element, like this. But it's not going to work for the very first element because we don't have anything here. We will assume that the first element has the left neighbor as of 0. And now we actually need to mm, to subtract a number from nums e, right? So it needs to be at least one bigger than the pref, like this. So minimum, yeah, this should be the minimum possible value of nums I. So basically, we will try to remove this value from nums with index E or I. I'm not sure how to spell it because E is Latin, I is English. I'm definitely not Latin, but I'm also not in English. So let's call it E, ith element. So this is how much we will going to try to remove from current element, but we should check if this element is the prime. For example, we cannot remove 10. If the difference between those two numbers is 10, then we should try to remove only 7. So we are going to find the maximum possible prime that is less than or equal to the difference that we can subtract from the current element, like this. However, if we should track the case when we are falling out of the array. So basically, this difference has to be at least 2, right? Because 2 is the smallest prime number that we can deduct here. Oh yeah, actually, let's instead of calling it remove, let's call it deduct. Hope that I'm using the correct verb. And we make sure that deduct is at least 2. Okay. So what do we do now? We modify, we deduct. Like this. And let's see what we get in the end. Okay, here we got 1, 2, 3, 5. Nice. Here we got 1, 3, 4, 5. Also nice. Here we got 2, 3, 4. That is not okay because how can we get those numbers? 5 minus 3 equals 2. Okay. 8 minus 5 equals 3. And 3 minus 1 equals 4. Okay, so here, if the number that we are trying to deduct is not a prime number, like this, it means that we cannot deduct. We should return false. And here we should return true. Let's see how it's going to work for us. Okay, we are passing all the test cases that we had along with the statement. Let's try to submit the solution. It's not working. Why? 998, 2. Okay, what do we do with 998? We subtract 997 and get 1. And after that, we have an array of 1, 2. Aha, but when we get array of 1, 2, here we don't have to deduct anything, basically. So here we can add a special check. If current element, yeah, we can do it here. If current element is strictly more than previous element, more by 1, right? It's 1 plus 1. We can actually do nothing because it's already the minimum possible value. We should not apply operation to it. Okay, let's use this test case and check if it's going to work. Okay, it's working. Let's see, what do we have now? Okay, we have another that is not working. We return false. Okay, what's happening here? From here we can deduct 7 and have 9. From here we can deduct 3 and have no. Okay, let's see. Let's see here before we return. What do we have? Let's run this code. What's happening here? 2379. It's actually, yeah, it's working, but it's for some reason. Aha. So here we have 9, and we are about to, yeah, and we cannot deduct anything from 9, but we should be. We should be passing this as okay, because we don't have to deduct anything. Aha, you see, here we only covered when the difference is 1. Okay, something stupid. But I'm not sure that it's a good idea. Okay, it's passing strangely. We did it. Okay, I'm surprised. I thought that we should have to do some more elaborate checks here, but apparently this is also working. Okay, uh, thank you for watching it. Please write in the comments why do you think that this solution is stupid, and maybe there is a more intuitive one or easier one. I haven't checked the hints for the problem, so it might be the case here. Please subscribe to the channel, share the links in your social media, or don't, and come back to check the new videos tomorrow.